All right, so we will look at the quadratic function. Okay, this is the second type of function that we will look at. The name of the graph is a parabola. Okay, so in grade 10, what you did was f of x equals to ax squared plus q, where a is giving you the shape, the orientation of the parabola. If a was positive, then it was going to be concave up, which is the smile. And then if it was negative, then it was going to be concave down, or just sad. Remember, if you're a positive person, you always smile. If you're a negative person, you are always sad. So that is what we associate this with. Okay, then Q marked the turning point. Now the turning point also indicated the number of units the graph has moved up or down. So remember, Q just marks the movement of the graph up or down along the y-axis. So now in grade 11, we are going to just add one more concept on what you already know. Now, I just want, it's unfortunate that we are doing this over here. It would have been nice to see these graphs on your own. Okay, if we start with this black one, this black graph here, which is y is equals to x squared. And then x squared only just means x squared plus 0. So it means the turning point is at 0. So that is why I added that 0. Okay, now this blue graph, if you look at it, it's still turning at y equals to 0, and the graph is now 2 units away from the main one. And then the equation says y is equals to x minus 2 all squared. And then if you look at the purple one, this one, it is also 2 units away from the main one, which is the black one. And the equation says y is equals to x plus 2 all squared. If you look at the green one is 1, 2, 3, 4, 5 units away from the main one. And the equation says y is equals to x minus 5 squared. Look at the red one. The red one is 1, 2, 3 units away from the black one, the main one. And the equation says y is equals to x plus 3 squared. I don't know if you noticed the pattern here. It would have been nice to do it on Desmos, but again, we can't do it because we are here. So the discovery that I see here is that if you move if the graph has been shifted 2 units to the right, then it's going to be minus 2. So it's the opposite, because we know the right values are positive. So it's the opposite sign inside the bracket. So if you shift it to the right, you subtract 2 units. If you shift it 5 units to the right, you subtract 5 units inside the bracket, and then you keep the square as it was originally. Okay, and then also this side, if I shift it 3 units to the left, then it's going to be plus. Remember, the values on the left are negative, so it's going to be the opposite sign inside the bracket. So please don't forget that. So that is the only concept that we are adding in grade 11. That the graph, the equation is now going to look like this. If you notice, the A is still there, the same as that one. The Q is still there, the same as that one. So it still indicates the same thing, the turning point. The only thing that we are adding now, that inside the bracket, is that plus Q. And then the Q will indicate the axis of symmetry. Now, axis of symmetry is that line that cuts the graph into 2 equal halves. So if you notice here, if this is x equals to x minus 2, it means it will be at x equals to 2, positive 2. And then x minus 5, it will be at the negative of that. So it's like you are solving an equation. It's like you're solving an equation x minus 5 equals to 0. So this will give you x equals to 5, which is your axis of symmetry. All right, so this still indicates the orientation. Smile and said. This one is the turning point. Now the turning point, if you check here, turning point is at at 2, 0. So it is always going to be at negative PQ. It is going to be at negative PQ because we always write the sign that is negative to this one. So it's negative PQ. That will be your turning point. And then this will be your axis of symmetry. Okay, so P shifts the graph left or right, and then the graph if as the graph shifts, also the turning point moves. That is why now is normal one value. Remember in grade 10 you used to just say it turns at 0.8 or it turns at -5, but now it will turn at a point that is away from the origin. So it will be anywhere. Can be also here, it can be there, can be there, can be there. It will shift according to what is done to the graph. Okay, so to sketch this, we need the y-intercept. Same procedure, let x be equals to 0 and so for y. We also need the x-intercepts. Now the x-intercepts are going to be 2 because this is quadratic. So it means that we are going to have two values where the graph cuts the x-axis. Okay, and then please make sure when you sketch your graph that it is a nice U shape, not this thing that has now it's like a square bottom is not needed, and also it mustn't be a V like that. It must just be a nice curve that carries on. Okay, so I've got just two examples that I have done for the sketch. So f of x is equals to x minus 2 squared minus 4. Okay, so you do your analysis. My turning point, first point, my turning point is going to be at -2 and then -4. So it's going to be at 2, -4. So on your Cartesian plane, you mark the turning point. And then you find the the y-intercept by letting x be equals to 0. So you put 0 here. So 0 minus 2 is -2. Please make sure you put this in your calculator. -2 in a bracket squared will give you 4. So 4 minus 4 is going to give you 0. So it means the y-intercept is 0, 0. And then you indicate your y-intercept. X-intercept 0 is equals to x minus 2 all squared minus 4. And if you notice, this is a difference of 2 squares. If it is not, you take this to the other side and then you take the square root on both sides, making sure that it is plus or minus. Please remember, we need two answers. Okay, so this one gives us x equals to 4 or x equals to 0. Again, this is something that we have done already, solving quadratic equations. So that is why I'm not spending more time there. And then you mark again the x-intercept, it is there, and then the x-intercept, the second value is over there. And then you sketch your graph. So as you can see, the graph is not a U, like the lines are not going up vertically. They carry on in a slanting format. And then as you can see, the graph is smooth, and then you also have your minimum, because this is the last y value that you can have, which is -4. Okay, then they can ask you the equation of the axis of symmetry. AOS is axis of symmetry. It's at x equals to 2, and then the domain, all x values. There's nothing that gives us an undefined here, so all x values qualify. Then the range, the y values start at what? -4, and then they go all the way up to positive infinity. So you can write it like this, or you can just say it's all y values that are greater than -4. Greater or equals to -4 here. Greater or equals to -4, like that, right? Then second equation, second example, now the graph is upside down because this is negative, and then it still turns at 2, -4, which is what I have done here. Now if you try to find the x-intercept, it will give us a no solution. The reason is that when you try to take the square root on both sides, this is non-real, so it will give you an error in the calculator. But that doesn't mean we cannot sketch. We can still sketch. Remember, this is it turns at 2, -4, and it is a third, so it's upside down. So we can still sketch it like that. So it means if the A is negative and the Q is negative, then it will not cut the x-axis. If the A is positive and the Q is positive, it will turn before it reaches the x-axis up there. So just keep that in mind. So if the signs are the same, then it will not cut the x-axis. But if the signs are different, like in this case, this one was positive and this is negative. Sometimes this can be negative and this can be positive. So it means that you can solve there for x, and then you can find the two values. Right? I hope that it's clear. Please do exercise 3, page 98, number 1, B, D, F, H, G, and J. Thank you.